Hi, here's another opportunity to learn a new skill in mathematics. Before us, here we have a junior math Olympiad question, and I consider this to be one of the toughest algebra for junior math Olympiad. The question reads, say bracket open x, y minus 7, close bracket all to the power of 2 equal to x to the power of 2 plus y to the power of 2. Find the positive pairs of x and y that will satisfy this challenge, this math problem. So if you're new here, remember this is All I Maths TV. And if you've not subscribed, do it to subscribe because here we roll out math solutions all the time. So without much waste of time, let's go into today's challenge. Okay, so we take the first thing, which is always selection. So let's write down our selection here. Now, the first thing we're going to do here, we want to use this power to open up everything here. So if we open up this is going to give us here x squared, y squared, right? Then here minus this will give us here 2 into x, y, close bracket, bracket 7, close bracket, then plus, here will give us 7 squared equal to, let's keep this side squared, y squared, yeah. Okay, so what we do here, we can now use this to open this and find the numerical value of this. So we're going to have here x squared, this is x please, then y squared minus 14xy, then plus 49, this is equal to x squared plus y squared. So what the next thing we do here, we want to rewrite this side of the equation. Okay, remember your algebraic identity, which says that if you have a plus b all squared, this is equal to our a squared, then plus our 2ab plus our b squared. You remember this? Good. Now, with this, what we do, we can bring this and this together to give us something like this. So rewriting this will now give us, let's keep this at x squared, then y squared minus 14xy, then plus 49. This will now give us, remember this, then we can send this to this other side. So we can now rewrite this as our, here we're going to have this to be our x plus y r squared, then minus 2xy. According to this, we can express this in this format. Because if we move this to this side, we're going to have something like this. They're leaving us with x, a squared, b squared. Yeah, a squared plus b squared. Okay, so your xy here, we also have xy here. So let's move this to this other side. So this will now give us x squared, y squared, minus 14xy. This crosses the sign of equality, turns to plus 2xy, then plus 49, okay, equal to, we have this plus y r squared. Okay, so this automatically will give us minus 12xy. So we have x squared, y squared, minus 12xy plus 49, then equal to bracket x plus y r squared. Okay, so what we do here now, from this expression we have in here now, we're going to do something very crazy. What is that thing we want to do here? Here we are having xy all squared, we are having xy here, and this is a perfect square. So like you normally do in your completing the square method, whereby you find the half coefficient of the variable, right? So want to find the half coefficient of this expression we have here now. So half coefficient of this will give us here 1 all over 2 times 12, right? Which is equal to 6, right? So if it is 6, what we do, look at this sign here. So it's going to give us minus 6. We add it to this side. At the same time, we add it to this side. Remember, in your completing the square method in solving quadratic equation. Good. So let's do that. If we do that, we're going to have this to be x squared, y squared. Okay. Then here we're going to have here minus, okay, let's still put this down, minus 2xy then minus the bracket minus 6r squared plus 49 equal to bracket your x plus y r squared. Then we have here minus, sorry, plus here bracket minus 6r squared. I believe we'll learn something from here. And don't worry, everything will be clear. And remember, immediately you add your half coefficient, the square of the half coefficient of this term here to the system. What happens? This guy leaves the system. So we can bring this and this together. You remember? Okay, so let's continue on this side and see what this gives us in turn. Together, so we have here x squared, y squared, minus our 6 squared. Okay, which is this. Then here we have here plus our 49 equal to this will give us the bracket x plus our y r squared, then plus 36. Okay, so what we do next here is easy. We can rewrite this to here. So this will now give us here bracket x y minus 6 r squared, then plus our 49, everything equal to your bracket x plus y r squared plus 36. I want to rearrange this system here. Okay, if I move this to this side, move this to this side so that we can have positive stuff here. So we're going to have here 49, okay, minus 36 is equal to, this comes first, x plus y r to the power of 2. We'll move this to this side to give us here bracket xy minus 6 r squared. This does not change anything, or okay, so if we subtract this from this, we end up having, again, I want to move this to this side, rearrange it, so this will give us 13. So we're going to have here our x plus y r squared minus bracket x y minus 6 plus bracket r squared equal to 13. Oh, so look at what we want to do here now. Or if you check this very carefully, this is a difference of 2 square. Okay, remember, says that if you have your a, then squared minus b is b please squared. This is equal to bracket your a plus b bracket your a minus b. This another special identity we're going to make use of here. So the whole of this is our a, the whole of this is our b. So if we have this to be a and this to be b, let's express this in this format. So this means that we're going to have this to be, our a is x plus y, okay, then plus our x, y minus 6 close bracket. Let's bring a square bracket in here. So this is going to give us here our x plus y, right? Okay, close bracket, then minus bracket. Here we're going to have our x, y minus 6 close bracket to our square bracket, everything equal to 13. This is ridiculous, right? Okay, so we move again. We can use this to open up this. So we keep this side here. So we have here bracket x plus our y plus x, y minus 6 close bracket, bracket our x plus y, then minus x, y plus 6 close bracket is equal to 13. Okay, so what we do here, we are having this times this, and on this side we are having 13. So if we decide to, split this, the only two factors we are going to have from there is plus minus 1 and plus minus 13. So what does that imply? We equally express this as this could be to your plus minus 13, then this will be also plus minus 1. Again, we can equate this to your plus minus 1, and we equally express this as plus minus 13. You get what we do here? Yes. So if that is the case, so let's take the first case here. whereby we are going to equate this to our positive 13, then this will now be to our positive 1. And second case scenario, we equate this to our negative 13 and this to negative 1. Then the third one will be this to our positive 1 and this to positive 13. Then this to negative 1 and this to negative 13. And see which of them will give us a positive pair to our x and y. All right, so let's take case 1. So we're going to take our first case. So we're going to have here x plus our y plus our x, y minus 6. This is equal to, we are taking the first one, which is positive 13. And so this will now be our x, then plus y, then minus x, y, okay, then plus 6. This is equal to, we're taking it to positive 1. So let's call this equation star. Okay, so this is the first case scenario. We're taking it as equation star. Let's take the second one. Let's continue on this side of the board here. We're going to have our x plus y plus x, y minus 6 equal to negative 13. Then the other side will give us x plus y minus x, y plus 6 is equal to negative 1. So this is case 3. So let's give this equation star. So we'll come to this other side. We're going to have positive 1 and positive 13. So we have here our x plus y plus x, y minus 6 equal to, we have our positive 13, right? So we have this to be, positive 1. Then we're going to have x plus y minus x, y plus 6 is equal to positive 13. Let's take this as our equation star. Okay, then the last case scenario is going to give us, giving us negative 1 and the other side negative 13. So have here x plus y plus x, y minus 6 equal to our negative 1. Then x plus y plus x, y plus 6, right? Yes, minus, please. Yes, minus. So minus x, then equal to negative 13. So we're going to take this as our star. Okay, now if we check through, let's see the one that will give us positive pairs of our x and y. Of course, our first case, if we add up everything here, what will that give us? That will give us positive. But if we add up everything here, this will give us negative. So automatically we're going to reject this one. This one is rejected. Again, if we add up this will give us positive. So this one will be accepted. Okay, so this is giving us positive. Even as this other one is giving us positive there, this will give us negative. And so we reject this one also. Okay, so let's reject this one. This one is rejected. So we are taking only two case scenario here, which is our equation star and our equation star. Okay, so let's go on with equation star. So we're taking from equation star, All right, so let's rule out this. So we move this to this side. So minus 6 to this other side, that will give us 19. So automatically we're going to have our x plus y plus our x, y minus, equal to your 19. Then again, we move this to this side. This will give us a minus 5. So we're going to have here our x plus y, then minus x, y is equal to minus 5. All right, so what we do to these two equations, we want to add these two equations together. So let's add up this. If we add up these two equations, what will happen? This and this will leave the system. So we are left with this. And here we can equally add up this. This will give us a positive 14. So let's continue on this side. So yeah, we're left with this. So this automatically will give us bracket your 2 bracket x plus y close bracket. This is equal to this will give us 14. So divide through by 2, so we have here x plus y is equal to 7. So from here, we want to make y the subject of the formula. So we have here y will now be equal to 7 minus our x here. So let's give this equation 1. Let's give this equation 1 because we've not had equation 1 before now. All right. So what we do from this, look at the first expression here. We can put in this value into this place here. Okay, so from equation 1, based on this part here, or from this equation, because we have that to be equation 1. So based on this equation, we can substitute 7 into this place here. So this now becomes your x, y is equal to your 19, then minus 7. Any confusion? No, right? So if we have this minus this will give us what? 12. So we have x, y is equals to 12. So here we made y the subject of the formula already. So from equation 1, we can put in your 7 minus x here. So this now implies that your x is into our 7 minus x, everything equal to 12. So if we open up, we're going to have here 7x minus x squared equal to your 12. Collect your items. This will give us here, or let us multiply by minus here. So this is going to give us x squared, right? Then minus 7x, then plus your 12 equal to 0. I believe we are not confused here. So from here, we think of two numbers from the factors of 12 that when we add there will give us minus 7 and multiply there will give us plus 12. And that will give us minus 3 minus 4, right? So we can now rewrite this as x squared minus 3x minus 4x there plus 12 equal to 0. So we can put this in bracket, also put this in bracket also. So what is common here is just x. So we're left with x minus 3. Bracket, what is common here is just 4. Here we're left with x. This time this will give us minus. So here we have 3 equals to 0. So again, we have this to be same. So we now have this to be x minus 3 with bracket, your x minus 4 equal to 0. So we have our x1 is equal to positive 3, or then we have 4. Okay? So let's just take ordinary x here, not x1. So we have our x is equals to 3 or 4 from here. So now we have this. We can look for the value of y from here now. From equation 1, we can substitute for y. So how do we substitute for y? Let's just manage the space here. Okay? So from equation 1, we know that our y is equal to, we solve for our x to be 3 here, so this will now give us here 7 minus 3. So we have y is equal to 4. Okay? So for our x1, we have y1 is equal to this. So this y1, so y2 will now be 7 minus 4. So minus 4. So we have y2 is equal to 3. So we now have your y2 to be this, the x2 to be this, y1 to be this, the x1 to be this. Okay, but let's go ahead and check for the other pair we said will give us positive, which is this here. Because we rejected this. So let's handle this and see what this gives us. Okay, we are almost there. All right. Okay, so from here, we can easily rewrite this, move this to this side. So let's continue on this side. So we have here x plus our y plus xy will now be equal to what? This moves to this side will give us 7. So we have here positive 7. Then we do same thing here, x here plus our y, then minus xy. If we move this to this other side, this will give us minus. So 6 from 13, that will also give us positive 7. So look at these two equations here now. What we do, we want to add these two equations together. So if we add these two, this will leave the system. Again, so we're going to have this to be bracket x plus y close bracket equal to, if we add this, we give us what? 14. So we have here x plus y is equal to 7. Okay, so from here, if we decide to make y the subject of the formula, we're going to have here y is equal to our 7 minus x. Again, like what we did in the other case scenario, here we have this. So let's go ahead and put the whole of this into this system we have in here now. So if we do that, this will now going to give us here our x, y is equal to our 7, which is this, everything here, which is for this, move this way, now total minus 7. So we have our xy is equal to 0. Look at what we have here. And so if we apply this zero product rule, automatically we're going to have this to be x is equal to 0 and y is equal to 0. Now look at this. We added this and we arrive at this. What if we decide to subtract this from this? What will happen? This, the whole of this will leave the system. So we're going to have 2xy will now be equal to 0. So x and y will also give us 0 in this case scenario again. So what we do, or what is our conclusion from here now? Look at my deduction I made here. If we have x is equals to 0 and we plug that into this system here, what will be the value of y that will satisfy this question? It's just plus 7. And if we plug y equal to 0 and we put it into this system here, what will be the value of x that will satisfy the equation? It's 7. Do you get what I'm saying here? So we can now go ahead and bring out all the pairs or the positive pairs of your x and y that we from here and here, there, here, that will satisfy this whole system is this. So let's put it here. Okay, so we can now say therefore our x, y is equal to the first pair here we have here x3, y4. So we have here 3, 4, right? Close bracket, the bracket. Then the next one we have x4, y3. So we have here x4, y3. Then the next one from the deduction I just made here now will now be x0, y will be 7. Okay, so in fact, let me put it here. So here we're going to have here x is equal to 7 and y is equal to 7. So from here, we cannot include that here. So we will have our x to be 0. So x0, y will be 7, close bracket. And we will have our x to be 7, our y is 0. Okay, so these are the roots, positive roots of x and y that will satisfy this challenge here. I know this is kind of rhetorical, but I believe we'll learn something from this challenge here. Okay, okay. If you're not too clear, just go through the video tutorial twice, then you will get it. Okay, I advise my subscribers or my viewers to always go through solutions that are not too clear. Okay, the first time and the second time, I believe the third time it will become clearer to you. Okay, so this marks the end to this nice math Olympiad challenge. I believe it's one of the hardest. Okay, although I don't know if it is my approach that is the hardest, but if you have a better way of solving this challenge, drop it in the comment section. And if you like what just happened here now, then give this video a thumbs up. And if you have a better way of solving this, do not hesitate to put it in the comment section so that we can equally learn from you. Remember, this is All I Maths TV, and my name remains Jakes Animal. We love you, all of us at All I Maths TV. But again, I, Jakes, love you more. And stay blessed, even as you keep winning. Bye for now.